Hello, this is Valentine from Simplistic, and in this problem we're going to basically answer a question. We're given two compounds, FeCO3 and PbR2, and the question is which one is more soluble in acid than in base. Okay, to understand how to solve this question is we need to understand basically which one of these compounds is going to react with acid, okay? Because the one that's going to react with acid is going to be more soluble in acid than in base. So the key is to take each of the compounds and split it into their constituent ions. So FeCO3 can be split into Fe2 plus and CO3 2 minus, and then PbR2 can be split into Pb2 plus 2Br minus. Now if you look at each of those ions, let's try to understand if the ions are, if it's going to react with an acid, we're essentially going to focus attention on the negatively charged ions. So this one versus this one, okay? Because an acid is going to release protons, so that's going to be a positive center. So the positives are going to react with the negatives, okay? So that's why we look at the negatively charged ions. So between between Br minus and CO3 2 minus, what we need to understand is what are these ions conjugate bases of. So basically what we're asking is, if this had to come from an acid, what acid would it come from? Number one. And then number two is that acid going to be a strong or a weak acid? Okay, so if I extrapolate from this and write out the acid it came from, it would be H2CO3. Okay, so that is the acid it came from. H2CO3 is actually a weak acid. And if I write out the acid that Br minus came from, that would be HBr, which happens to be a strong acid. Okay, so now what we do need to understand is strong acids give rise to, or basically give weak bases. And what that means is once the base is formed, it will stay as the ion and will have no tendency to pick up an H plus ion. Therefore, in the presence of acid, which is what the H plus ion is, in the presence of acid, the solubility of Br minus will not increase. Now, if you look at H2CO3, that's a weak acid, so that gives rise to a stronger conjugate base, okay? And what that means is that CO3 2 minus is not very happy by himself, so he will readily look for an H plus ion. So if you put him in acid, he's going to grab the H plus, he's going to form HCO3 minus, and then he's going to keep going. He's going to grab another H plus to form H2CO3. Okay, so the equilibrium wants to shift this way. Therefore, in acid, because the equilibrium shifts this way, more CO3 2 minus has to be produced. Therefore, more of this is going to go into solution to generate the CO3 2 minus. Therefore, FeCO3 is the more soluble compound in acid. I hope that made sense. Thank you for watching.